I would like to welcome you to this facility where BitCloud stack is developed and tested by a wonderful team of ZigBee experts. We have about 100 ZigBee nodes here. They're all based on Atmel ZigBee modules. They're all distributed throughout the space. You see some test network frames mounted on the wall here. Just some examples. And this is how we test and verify the performance of the stack, the top performance and reliability that you have come to expect from BitCloud. The space, as you can see, is fairly small. So all of the nodes that are here, they can all hear each other. So air is very crowded and crammed with 802.15.4 packets. So this is a very stressful environment for the network. So what I would like to demonstrate for you today is how this very dense network of 100 ZigBee nodes works and how it operates.
So what you see here is the WSN Monitor version 2. On the right hand side, in the right hand area, you see a coordinator device, and there's a network which is growing around it, a network of devices. So we have over 100 devices here in close proximity to this coordinator. They can all hear each other. There's about 40 mesh beans. The rest of the devices are part of the test network that I showed you earlier, and you see now that there are new devices joining. If you look at each one of these devices, you can highlight it with the mouse. You see either a letter R, or you just see a little point. So letter R denotes a router device, and obviously routers have end nodes that are connected to it. As I'm talking, the network is continuing to expand. We're now up to a little over 50 devices that have joined. The WSN Monitor scales the devices so they all fit in this window. We now have 70 devices, about 70 devices, so almost all of the devices have joined. We're expecting more to join shortly. You see that on average it takes a network of 100 nodes to assemble itself. Takes about 2 to 3 minutes on average. We're now up to 80 devices. You also occasionally see these disconnected clusters, and these clusters are basically those clusters that are part of the network which the coordinator doesn't have the complete information about. So these nodes have joined, but the information about how their data is routed has not reached the coordinator. So that is the reason that they're shown disconnected. Eventually, we expect this network to all be connected. This graph. So every node will have a route, a unique route to the coordinator, and now you have we're up to 98 devices. I have to scroll now to show you the complete picture here. 99 devices. So we're almost there. I think we have another 10 devices that will join very shortly. You can see that there is 103 devices now. You also see that some of the nodes, some parts of the network are quite a few hops away. For instance, one of the segments here is 4 or 5 hops away. So we're up to 102 devices, and the network is still adjusting and building itself. 104, 105. On the left-hand side, you also notice that if we highlight a given node, you'll see the node parameters like the full address, short address, node type, the version of the software, and so on. We also have a history, and history shows the sensor readings that we got from this node. It shows the LQI readings, the short address, the light sensor readings. So mesh beam evaluation boards have a light sensor and a temperature sensor integrated. Those sensor values are forwarded to the coordinator and displayed here. For the devices that don't have those sensors on board, we just show either random data. Also, you notice that all of the links, the gray links between nodes, also have the numbers next to them. These numbers indicate signal strength. On a large network, these are scaled to a very small font, so it's difficult to see here. But otherwise, I show signal strength connection. Both RSSI and LQI values are shown. As you can see, the network is almost finished building itself. We have 111 devices now, and 112. I think all of the devices have now connected and joined. The coordinator has quite a few devices attached to it directly. The rest of the devices are several hops away. As you can see, WSN Monitor is very convenient for network visualization. You saw that the network view is updated dynamically, so it's easy to see what is going on and which devices are present or absent. You also see how the network constructs itself, what happens at the join time, etc. And it also contains useful information about the sensor data that is read by the remote devices. So that concludes our demonstration. As you can see, the network is now stable. There's no more movement happening. There's 112 nodes. All have successfully joined.